let's go get started. Now that we have the insertion sort, I'm going to go through another example of how you capture timings, so you have a clear idea of what's going on. Woohoo! Because what? So if you want to take timings, first you need to get the clock. I think it's called a clock. If not, we'll find out soon. Import clock underscore t will have start and diff. So we can have a start time and an end time. So if we were down here and we do start equals clock, and then down here we'd have diff equals clock minus start. Print the numbers, and then we'll go ahead and standard cout diff equals, just to show you what diff looks like. All right. Let me see if I typed any of that correctly. Not quite. It's not clock.h. Oh, it's probably time.h. There we go. So diff is some number that doesn't actually make any sense right now. But that's because if you actually want to compare it or calculate it, you need to make diff is currently in clock cycles per second, which is meaningless right now. So we need to So if we need to convert, so we'll make a double elapsed time. So the elapsed time will equal diff times 1.0, making it a double, and then divided by clock. Was it clock per second? What was it? Or is it ticks per second? Oh, I forgot. No.
I think it's clock per second.
Where is, there's a clocks per second. There we go. I was so close. Clocks per second. And that'll give us the elapsed time, so we can now do elapsed time, go over here, and print that guy out. So 0.05 seconds. Let's stop printing out these numbers. We increase it another order of magnitude. Let's see what we get. Oh my goodness. There we go. 5.5 seconds. Okay? All right. So now we have at least one way. Yeah, how do we make a graph from that? That is a great question. You do. All the good ones.
Oh, apparently Dawson's my best friend now. Ouch. She gave us candy in class yesterday in discrete, and I opened up the Reese's, and it had like a printed on part with BFF on it, and I was like, when are your BFFs with the teacher?
I didn't get
And
candy.
she just started.
Yeah, I never get candy. What's up with this?
I also
What?
like cupcakes.
This is an outrage. Whenever I see candy, there's always
Well,
something in
we should have this class on Valentine's Day. I might have brought
so
food
many
then.
prereqs for discrete?
We didn't.
Prereq for discrete?
Yeah, isn't there like it's like cow?
2, I think.
All right, well, back to data structures. So here we got the
It's all
we have the ability to get the elapsed time for one run. So we need to set up a for loop to do multiple runs,
Yeah.
right?
Yes.
Based on the data size. What is the data size here?
Good size.
Over 9,000. It is over 9,000. But it's the size, the number of numbers we're sorting. Over 9,000. Okay.
Yeah. Size.
So let's go ahead and set up int. We'll call it n. And we'll start with 1,000. We'll have n is always less than size. We don't want to go bigger than size. And we'll have n plus equal 1,000. All right. Ooh. What?
I'm so used to seeing N++.
Okay. So this would run insertion sort on that number, actually. And we pass in n here. What does that do? It actually,
Ooh, sorts.
but it's only going to sort up to that size of n. So that's a way to limit the size. Right?
Sure.
That's right.
That's right.
Professor's always right.
Now the problem here is every time we sort it, if we go, we're going to be sorting the same numbers, just adding another 1,000 to it. So it's not going to be a real good estimation. Excuse me. So we need to refresh those numbers, basically reset them to the way they were beforehand. Right? Because if we, you see what I'm saying? Okay.
Yeah.
So if we want to do that, we should also, instead of just the numbers, we should create a, what should we call it?
Flag.
Not flag.
Sort.
Test.
It's the base. It's the,
Original?
oh my goodness. What?
Head.
Head? Not head, but I like original.
Origin.
We'll have,
First. Second.
it's the set, it's the,
Name it,
oh,
Name it Shay.
oh. No, we're not naming it Shay.
Carly.
You gotta give it a good
Carly.
name. Shay, oh, it's escaping me right now. It's the set, it's the base set, it's the experiment set.
Google it. Start Googling all those words.
All right, I'm just going to call it the original set.
Sorry, Dr. Wells.
Original set. So original set equals numbers sub I. So the original set will be another set of integers that always keeps track, or is going to represent what the original set was. So, so here we get the timing. We print the timing, and actually right here we convert timing to seconds. And then now we need to reset numbers to the original values.
Missing that. Yeah.
Original. There we go. All right, so to do that, we'll do for int I equals 0, I is less than n I plus plus, number sub I equals original set sub I. And that'll reset them. All right. And we don't really want to look at diff and elapsed time. All we really care about is, first off, the size, which is n. Put in a space, and then the elapsed time. And then a good old new line. So let's go ahead and start running this just to see what it spits out, if I did anything correctly. Original set, probably because it needs to be original set sub I. Yeah, so it's going to start spitting out numbers. Now, obviously, it should make some sense that, hey, look, it's going to take longer and longer as we move along. But we want to store these values in a file,
And output it to the GNU plot.
and then output it to GNU plot.
Yay.
And we forgot to do one last thing. Never forget to flush.
It's TD. Yeah.
I think it's flush. Is that all I do?
I think so.
Yeah, that's all you got to do. All right. Why do I need to flush?
Valdrin,
It's best to-
because you'd be losing bytes then. I am going to keep because you'll be losing bytes then in that case.
Now
No, feel free.
you can be losing bytes, right? How could we lose bytes? Do you remember, Malik?
I was gonna say you would eventually run out of memory.
All right, so we have to flush because when you print something out, it's sent to a buffer. It's not necessarily sent to your screen or to a file. Flush, just make sure you flush it all the way to the end to the file so it's actually written. So never forget to flush. Hopefully that helps y'all out. So if we're over here,
This isn't the first time you've
no. And then we dump that to an output file. We hit go. It's going to take it a while. Let me load up another terminal. Let me go back into it. Let's see, we're at 315 class code, and we're doing insertion sort. Great. So if I did a head on out, well, it's only that far. Do it again. Looks like it stopped. Uh-oh. Why'd it stop? Who broke it?
Sorry.
The one coding
It was me.
It did stop.
Broke it.
Was it because you left the window, or?
No. So just keep going. Oh wait, I did the wrong. I'm sorry. I was running head. Silly me. I meant to do cat. Cat out.
Cat out.
So it is actually appending to it. All right. So if we want to plot this, good new plot. So we want to plot, and I never remember the exact commands. So the best thing to do is head over to my lecture where I told you what they are. Yeah. So 05, where did I do performance analysis? There we go. And all right, let's just click on it. For tips and gotchas, because that's what I like. So you can plot single timings using 1-2 line. Great. So the file is called out. So we'll say first, just automatically figure out my X and Y axis. Well, the file's from out using 1:2 with line. Okay. It's growing.
It looks like it's been square.
It does look in square, doesn't it? Look, every time I run it, it gets bigger.
Whoa.
It's over 80,000. That's actually stronger than Goku.
Only in the Vegeta arc. Okay, so that's how you can plot it, but we want to plot it to a file, don't we? Don't we?
Yes.
Yes, we want to plot to the file. And then we can also do set X label to be data size, set Y label to be seconds, and then we can plot it again. And hey, look, data size and seconds. Isn't that nice? What?
Yeah.
Whoa, dude. Okay. But this is all annoying to type in.
Yes.
So I highly suggest you make a plot file. Insertion. I'll just call it sort.plot. Sort.plot. Oh yeah, gvim, you're right. Tab new, sort.plot. And it's a lot easier to just copy and paste what you want into it. So set terminal post script color. And then we want to do what? Output? Alright. Set output to, let's see, insertion.p, or we'll call it sort.ps. There we go, sort.ps. And then what do I say? Okay, so now we can do the set Y label to be time in seconds. And set the X label to be the data size. Great. And then now is where you want to put in your plot. So like just right here. So you do plot, automatically figure out the axes for me, out using was it 1:2?
Yeah.
Using 1:2 with line. Save that, we go here. Now if you do GNU plot on sort.plot, it doesn't, looks like it didn't do anything, but if you did an ls, it created a sort.ps file, but you need to convert that. So you can do, whoops, p2, ps to pdf, there we go, on sort.ps, and now you can evince the sort.pdf. That seemed like it took a long time to figure out how to do all that. So what I always recommend doing is you just have a makefile, which does all those commands you just said. So p2, ps2, pdf, sort.ps, and then events, sort.pdf, and of course we need to do a GNU plot on the sort.plot. So now when you do make, it just does it.
I like it.
I'm glad I'm recording because I just did autopilot. So you'll probably want to watch me slowly do all those things.
That was a good review.
Yes, I hope that was a good review.
Now, how do you put them all on one graph?
Okay, how do you put them all on one graph? Well, let's say, for the sake of argument, is this one done? Yeah. So we want to put it on out 2, but let's try and make the timings a little different. And I'll call it out wrong. There we go. Because it's going to be wrong. Because we're going to not reset the numbers afterwards. Alright, so now it's going. So now the question is tab new sort.plot. So out using 1, 2, you can also do quote out dash wrong using 1:2 with line. Okay, so that's just going to add another one to the end of it. And you type in make, and there it is. Now that's as far as it's gotten so far. So if we do make again, it's gotten a little further.
So what if you did with line there? Like,
So that's why, well, why do we have dots here? Shouldn't that be a...
Two different.
Oh, okay. Oh, if you don't do with line, I don't know what it does.
Let's try it.
I was just curious. I was like, what else would you not, you know,
Oh, it makes little X's. Now, if I recall correctly, there's a title command. Let me see if I can remember this off the top of my head. Oh, I was right. So you can notice I changed that one to insertion sort to be the red line. And then with this one, I can do title insertion no reset. Insertion no reset. And now you have the full graph. Hey, that one actually looks fairly professional now.
So it automatically does different lines.
Yes. It starts with the Christmas colors.
Of course.
There could always be Christmas in July.
Is it blue and third one?
Probably. Are you okay with that? I'm sure there's a way to change that. You sure? Okay. I mean, we can go Google it right now.
I mean, I want to know what it does instead of dotted lines.
That's a good question.
You got solid, you got dotted. Then do little stars next.
Ah,
I thought you said you could set it though.
You can set it, yes.
Yeah, okay.
I just don't know off the top of my head. All right. Any questions?
Is that it?
I mean, yeah, that's it. What else do you need with the performance gathering? It says commit the code so you can copy and paste it, which I'm perfectly fine with. Perfectly fine with. No issue there.
So how would you do it with the linked list? Because,
So how would you do it with the link
because
list?
with those you have nodes.
All right. We'll talk about the linked list version in a moment. But any questions on the insertion sort for the array or the performance gathering?
Not yet.
Not yet? All right. Let's see if it finished it out. Yeah, so if you don't reset it, there is actually a significant jump.
So make sure to reset.
Yeah, make sure you reset. Why is that here? Ooh. Why is there this huge performance difference by not resetting?
Is it doing it wrong?
It's doing. If it's already sorted,
It doesn't have to sort as much.
right? Because if all these numbers are sorted up to here, it's not going to do anything. It's not going to swap. It only needs to swap when you add more numbers. All right, great. All right, let me make sure that I commit everything. Okay, commit -m. We got insertion, sort, code, and performance analysis. Git push. There it is. All right.